ChatGPT cannot answer this question. Yes, Vaishnavi.
So, because first you haven't informed that whether you are having a dog or not. So that if you inform it, by that information it can take and it can say that the dog belongs to you or not.
Okay, then I will ask a different question. Okay, do actor, for example, I don't know, some actor, Chiranjeevi. Okay, here I didn't provide any information, but it knows about Chiranjeevi and he says like it's a car, but I didn't provide any information. So what is your answer now?
Sir, it's a pre-trained model, ChatGPT.
Hmm. Okay, nice. Okay. So basically the ChatGPT is a pre-trained model. It means that it takes the information available in publicly, okay, and then it will train on that one. Okay, and when you ask a question to the ChatGPT about like the existing information, okay, so then it will try to provide the information. Okay, for example, let's go to, for example, um, like if you ask the same question, the chat GPT, let's say if some news had happened today, news.google.com, for example, if I go here and, okay, so if I ask some question related to for example, like, okay, if Trump meeting in Zelensky in, for example, in Florida, if I go and ask the same question, it might not answer. Like, okay, when is the next meeting of Trump with Zelensky? It might fail to answer it. Okay, so why it can't answer it even though this information is public is because the chat GPT models, like, okay, whatever we are using it has been trained for the past data, means that so every model, like, they will be need to capture the data, and then they have to process the data and then make the data available to the language models, then only it can answer. So it always having a very old information. So why it cannot answer my question here is like, whether I have a cat or like, okay, Rajendra is having a dog. Okay, because that's not a public information. Okay, and that information was not, this LLM model was not trained for that kind of an information. So how to make that LLM works even for that particular kind of a data. So here the dog Rajendra is having, or a cat I'm having, are my personal things, like my private things. Okay, I don't want like disclose or like, okay, anything in the public. So, okay, so when we need to make like LLM models work on those private kind of a data, okay, then with the approach what we take is the RAG. So the RAG will try to provide a, for example, like generative AI capabilities for your private data using the LLM models. So that is the purpose of the mainly the RAG tool. Okay, let's look into, okay, this is about like more about like in a very high level overview what is the RAG means. So okay, for example, like, okay, here you see that I will ask a question to the chat GPT that, like, as I mentioned to you, how many rooms in my house, for example, or in your house, like, okay, so for example in Bennett's house, okay, for example, so LLM cannot make answers for that one because that's a private data. Okay, sometimes you might have it might answer a question. For example, let's say, for example, like, what is the color of my cat, or for example, something like that. Okay, so it might give sometimes an answers. So you might feel that like, even if it is a public information, when you ask the questions, it might not give a very relevant answers always. So there's a high possibility that, like, okay, answers what it provide might be wrong. Okay, generally that is called the hallucination. So it means that LLM models are trained in such a way that if that question is more generic onto the public, so it never say that like I don't know. So it will try to, find a relevant information, and then it will try to give an answers. That answers may not be exactly the true. Okay, so that's the reason, like, many people will tell that, like, okay, don't trust 100% the chat GPT. Okay, the reason is that, like, it never say a no for a generic information. It always try to retrieve some information or the other information which seems to be the correct, but not exactly the true. Okay, so that's called like hallucinations. And LLMs, again, like it has an outdated knowledge, as I said that. For example, like if you ask something happening around, like, which is happening in recent time or latest, okay, then, like, it will try to, it could not able to find it because these models have been trained maybe like in a week back or a month back, or like, or like, okay, like for example, 4 months back, depend upon like how that particular company is, moving forward. For example, Gemini, or like, Google Gemini, or like, okay, Chat GPT, for example. Okay, so and the context length limits. So another problem with the LLM models is like, okay, how much context you are sending. So it cannot have a, unlimited memory of data for your context. Context in the sense that whatever the relevant information you are providing to the LLM, so it has to work in that session, and then it has have a limits on the amount of the memory. Let assume that for the discussion purpose, assume that like it can only hold 10 lines, for example. Okay, when you ask the 11th question, and the 11th question, for example, okay, then automatically the first line in the memory will be removed. So anything related to that particular first line will be, excluded when it is responding back. Let's say the first line, you might say that always answer me in the red color, for example. Just assume that like that is the context you have provided to an LLM. Answer me always in the red color, and then you start asking the questions. It will try to answer it back to you in the red text. Okay, after some time, okay, when the context is full and then the first line is removed, then you ask the question, then it will come back to a normal stage. Means like it will just show in a black color, for example, the text, because it lost the memory of that particular. So that's why, like, this context is having a length limits here when we talk to the LLM. And then the like as we discussed, the private data. So the private data is, is the one like what we asked for. For example, like what is the name of my cat, or like, okay, or like, okay, so someone's dog name, for example. Okay, it cannot answer those questions. So what is it tells to us? For example, like, LLM is always a past. So LLMs only can answer the past data, not the current ones, or like, okay. And RAG is always a near past. So what is meant by near past? Means it can be like, lost in 1 hour, or like 1 day, or like, 1 month. Depends upon like how you implemented the RAG. So, or like it can be 1 minute, 1 minute past as well, but not the live data at this moment. The RAG is always a near past. It can be half an hour, it can be 5 minutes, can be of 10 minutes, whatever it is, but it's a near past. LLMs are always past. And then when we come to the MCP, the next topic, the next week topic, MCP, for example, okay, that is present, or like in APIs, for example. So these MCPs and APIs answers the present data. That this moment, like what data we have, that information will be provided by MCP or APIs, for example. When it comes to the RAG, it's near past. Maybe like 5 minutes past, 10 minutes past, something like that. Okay, and LLMs are always, like as I mentioned, that like, it's a bit of old data. Maybe it can be like 1 month or like 15 days, depend upon the company how they are implementing it. So LLMs cannot answer, like for example, like as we discussed, the private data for like the internal documents. Let's assume that like, okay, you have a company, and you have like uh, or your company related data, either it can be a bug reports, or like it can be a requirement specifications, or it can be policies, company policies, or anything, like for example. So they're all like internal data, and that need not to be exposed to the public. Okay, so that kind of a internal data, okay, LLM cannot answer. So that is the place like where we use the RAG to access this internal data and works with an LLM, just like an LLM, for example, generative AI. So if there is some recent changes has been made in the document, for example, okay, so that changes are also not cannot be answered by LLM. Of course, you can train your you can have your own LLM model. You can develop your own LLM model with your internal data, internal docs. But still, as I mentioned, that is a past data. Okay, the reason is like again to have a new data into the LLM. Okay, again you have to retrain entire model. Okay, and then make it available. So training the LLM models is a very expensive task, and it takes a really very long time to build a model. Okay, for that reason, okay, every day you cannot, or like every minute or every 1 hour, you cannot train the LLM models, okay, with your internal data and then make it available. So that's why this RAG kind of a implementation will be used to overcome those kind of a problems. Like means that you can use the LLM model on your private data using the RAG implementation. So what is this RAG means? So retrieval augmented generation. So what in a big picture, like okay, what we look at in big picture is find the relevant information first, okay, and then generate an answer for that one. Okay, so what it means, find the relevant information first. Okay, that is nothing but a search for the information. And then, like generate an answer for that. So use the LLM to generate an answer for that particular purpose. So search, get the information, use LLM to generate an answers for that. Okay, so retrieval augmented generation. So search for the relevant information, the same thing like what I explained. Okay, search for the relevant information. So where do you search for this relevant information is that like, okay, you have a private data, and then using that private data, you are going to, prepare a RAG model, for example, and then you search in the RAG for the required information, which is private to your organization or like you, for example, and then use that particular retrieved information, okay, into the model, and then ask to generate a language in a, for example, natural language responses. So having these three steps is the main part of this RAG implementation. So the RAG implementation is very simple. Okay, it is having very less number of steps. Okay, so it's easy to implement. Anybody can implement this RAG without much pain. But like making the when you are implementing this RAG, so the very first part is making the data to the searchable. Okay, that is the place where you need to have a bit of an experience and domain knowledge, and okay, these kind of things. So we will look into that one, like okay, when we near to the topic. Okay, the most, for example, if you look at the data science, so what is the most difficult task, for the data science is making the data clean and making the data quality before you even apply the model. Applying a model is a simple task. Okay, so once you identify the what model it will be useful for that particular kind of a data, for example. Okay, applying a model is a very simple task. You just call a Python library, and then you provide, for example, train data and test data. Okay, and then you calculate. Okay, so for example, R T squares, for example. Okay, and then you if you have a satisfaction probability on that return, like then yeah, you use that model. Otherwise, like again, like you have to fall back to the most complex problem, that is again like the cleaning the data, or like okay, adding a extra features, dimensions to the data, for example. So the major part of the problem with the machine learning is the cleaning, and then adding a features or like a dimensions for the existing data, so that like you have a better probability, success rate when you use that model. So similar way for RAG as well, like, making the data available, like for that, like, okay, so how efficient you clean the data, okay, so how efficient, like you fine tune the parameters, okay. So overkilling is a problem, okay, we'll see that one, okay. So overkilling is also a problem, and then like underestimating is also a problem when it comes to this RAG. As I mentioned, like that when you convert the data into a searchable item, so that is the most complex to like implement. But for the understanding, it's easy. Like, okay, it's a straightforward thing. But making that particular a searchable element more efficient, okay, it become a costly affair. So when we are doing this demo, we may not have that problem because we are not doing it in a very high volume of data. We are doing it on the very small quantity of data. So that may not be appear as a like a problem here, but we try to induce some kind of a like problems in that one, and then I will try to show you like, okay, what it is. Okay. So assume that, like, I mean, there is a company called Aurora Tech Solutions. For example, like, okay, so this company is having this financial data for the last couple of years. Okay, so when this particular data is belongs to a private, for example, your company, your company, and then like when you ask the data to the LLM, for example, okay, what is this 2023 Aurora Tech review revenue, for example. So we should able to tell the answers by the LLM, for example, when we have this RAG implemented. Or like you can ask average revenue in the last 3 years, for example. So LLM should able to answer these questions with the help of RAG. Okay, so what it is, like, for example, like as a user, so we ask the questions to the agent, for example. Okay, and the agent talk to the RAG. Okay, basically when I say RAG here is like more, it will talk to the vector, for example, vector database. So the vector database, how the vector database get these processes, like we'll process the documents into a vector database, and then like we supply that to the agent, for example. So converting this data and then implementing like a search, okay, all this thing is called basically like in a kind of a RAG, like where the LLM or search, as I mentioned, it's a search, get the data, relevant information, and the LLM. So these three steps is called the RAG here. So in this data, we are going to have a question to the, for example, LLM model to retrieve the information which is relevant to the private to my organization, or like, okay, for example, my data, my private data. So what is the primary, the benefits of like when you use this RAG? Okay, so basically, like, it's an accuracy. So accuracy in the sense that we are not, relying on some frictional information which is available on the LLM model. So what we are trying to do is we are using our own data, our own documents to the RAG. So it means that like it's grounded to the real documents, not like some hypothetical or something like that which is there available in the model. Okay, the freshness. So basically, like it just gets the instant or like an updated docs. As I say that when I say instant, so it is just near past. Okay, so not the live. Okay, near past. Okay, so it gets the fresh data without even retraining the models. As I mentioned that we don't train the LLM models like with our new data every time, because it's a very expensive affair. Very expensive affair. It's not possible to do the new LLM learnings or like trainings for the data cost effective. So as like there is no model training, okay, it is just an embedding things on the database. So the cost efficiency is like the cost is really low. Okay, so no fine tunings are needed because LLMs needs a lot of fine tunings, retrainings. Okay, it's a lot of things are required when you are working with the LLM. But for this one, like RAG, okay, there is no fine tuning needed. That's quite cheap and it's cheap to iterate as well. So it means that, let's say you have a document and the document having a wrong information. Assume that when they're creating a document, they made a wrong calculation, then it's showing the revenue of like, okay, for example, 5 millions, but it is like a 4.5 million only, for example, because of some calculation they found it wrong. Okay, so then immediately, like they can update their own calculation process, and then they can generate a new document, and that new document can be easily pushed back to the to the RAG, so that, like, when you ask a question to the LLM, LLM can just retrieve that information freshly, and then from the latest updated document, because it was near past, it's already been processed and put it into the RAG. Explainability. Okay, so all, like, okay, so when you see some information, let's say for example, like, okay, what is the revenue for the last 3 months, for example. Okay, then it will give you a number. Okay, then the question comes is like, okay, how can I retrieve? For example, if I go to the chat GPT and ask, like, okay, what is the population in, for example, in this city, for example, it might give you some information there. Okay, now the question is, okay, how do we know that the information is exact or not? Okay, so there might be like a misinformation in multiple places, and the LLM will not guarantee that, like, okay, which information has been retrieved. Okay, there is no like accountability for that one. It cannot explain, like, okay, why it shows that number, for example. But here in the RAG, we have this explainability. Okay, like, okay, you can directly retrieve that document, whichever the document it has been used for processing. Okay, you can retrieve that document, and then you can see that information there, and then you can you can find that, like, so that kind of explainability you can make on this one. So enterprise readiness works with a private data. So basically, like, okay, so when you implement this RAG, mostly like you implement in the enterprise side. So it means that, like, you have to work with the private data. Okay, so now let's see, like, okay, as we talked about we talked about embeddings. Okay, we talked about RAG, and okay, so how this RAG do the retrieve this information, I mean, so that, like, I mean, that information is very relevant when we ask a question. So basically, the RAG, as I said, that, like, which is having a search. The search is done on the vector database. So this vector database, having the information, whatever the information we provided, will be in the embeddings. So what is this embeddings? The embeddings play a major role, like when we are working with the RAG. Okay, so what is the embeddings are? Embeddings are like, it's a numerical representation of a meaning. So it means that, like, okay, if you have some information, that information will be converted into the numeric. Okay, that's why, like, when we are searching for something, because it's numbers, so it will give a very relevant information, almost like a very relevant information, because it's working on the numbers, not on the text, like what you have provided. And then, like, it used, for example, like when you're searching something, so it takes a similarities. So similar meanings means, like, okay, the one which are close in the vectors. Okay, let's say, for example, let's take one example of okay, one example of, let's this two-dimensional chart, right? Like, I mean, like graph, for example, x and y, for example. Okay, let's take about a two-dimensional chart here. Okay, so if, for example, if you put like 1, 2, 3, 4, and then like 1, 2, 3, 4, for example. Okay, so it's easy to tell that, like, okay, this coordinate is 3 comma 2. Okay, this coordinate is 3 comma 2. Okay, assume that, like, okay, this particular information is, I mean, this particular information is the this numerical representation is from the meaning of, for example, dog. For example, let's assume that, like, okay, there's a numerical representation of a dog. Okay, then it's easy to figure it out, like figure it out, this position of this one. For example, like when you convert this dog into numeric, so it always says that like 3, 2 coordination, and then we can directly go to this place, okay, to this place. So then when this particular information is here, for example, a point, okay, the next points available around this one, for example, okay, for example, around this one are mostly relevant to the dog. Okay, mostly relevant to the dog. So when you look for a anything like, okay, for example, of a color of a dog, for example, a color of a dog. So when you convert this one into a numerical representation, okay, then it will come very close to this one, and then you retrieve a information around it. You retrieve a information around it, okay, and then you take all the meaningnesses of maybe this is having about the food, dog food, and this might be having the dog name, okay, and this might be having a color, dog color, and this might be having a for example, dog height, for example, something like that, okay. So when we retrieve all this information near to this information, okay, and then take the meanings of this, take all these meanings of it, and then you provide to the LLM, and then put the same question like to the LLM with this question. Okay, then LLM could able to map this retrieved information, and then it can tell you the color of it. This is exactly what happens like in the RAG. Okay, so for example, let's take as an example. Like now we are changing this one to little bit more efficient an example. Let assume that this is a, for the time being, this is a for example like a animal, okay, animal, or maybe like I will take it as a pet for the simplicity. Okay, so this is a pet coordinate, okay, and then this is a, for example, like food, okay, food coordinate, okay, and this one is for example like automobile coordinate, okay, and this one is the human coordinate, for example, assume that. Okay, now now this is like, okay, this is animal, okay, this is animal, like, okay, assume that these are all having like, for example, 0 to 10. Okay, so now if I use a cat, so if I want to bring a meaningfulness to the cat, okay, so now the cat is a pet. Okay, cat is a pet. So when I talk about the human and the pet, for example, okay, human and the pet. So a cat can be, okay, cat is definitely an animal. So it means that that point will be very close to the animal. Okay, very close to the animal, and also probably there are cats who are like in the street, they are not pets. So there are cats where like humans, the humans who are taking care about the cats, means those cats are very close to humans, and there are cats in the street, they are very far away from the humans because they are not cared by humans at all. Okay, so it means that like in this coordinate space, likely, for example, if this is 10, okay, this is 10 for example, and for example, like, okay, if you take this one, okay, if you take this one, probably the coordinate will fall somewhere here. Okay, somewhere here. So because it is, we cannot say that every cat is raised or close to the human. but every cat is a exactly an animal, very close to the animal. But some cats are raised by humans. Okay, so like this, it will try to bring a meaningful coordinate for that particular data. Now, when it comes to the food, okay, so for example, let's take a cat food or like some food, for example, like a bone, for example. We are talking about in a cat perspective. Okay, so this is far away from human and very close to the animal. I mean, like for the pet. If it is a rice, for example, then the coordinates will come very near to the human, very near to the human, far away from the pet. Because like, okay, rice, pet, I mean, cat unlikely eats the rice, but the humans eat the rice. If it is a car, okay, then car will fall likely to the, no other than human can use the a car, right? So likely it will fall in this coordinate, far away to the cat. Okay, so like this in the two-dimensional space, for every meaning like that, for every text what we are providing to this one, convert it into the meaningful numerics, and then like store that information. Okay, but now we are talking about only the two-dimensional. Okay, then the third dimension, I mean, like, okay, but what we have in the real world is a 3D space. Okay, so then like if you take this kind of a 3D dimension, okay, then if the cat is here, okay, then there will be a one property of like food here, okay, then car here, okay, and then human here, for example. Okay, so like this in the three-dimensional space, like we can put this particular information like this. I mean, like in this one, like we have a coordinates of x, y, and z, for example, in these coordinates. So when the data is increasing, is a three-dimensional may not be enough. Like, so it has to go into a multi-dimensions. So means that at one point, if it is working as a XYZ, okay, uh, for example, like this space, for example, if you take the z-axis, for example, this z-axis here, and this is the coordinate space here. At certain point, this will become as a coordinate, and then there will be a three-dimension space here. So what happens, like now it becomes as a multi-dimensional. It become as a multi-dimensional to store the information. There might be a some connection to this one, and then this one, and then to the this one. Okay, like that, this multi-dimensional space is connected to one to each other. Okay, depend upon the the word meaning, and then it's be placed here. So like this, the vector database will maintain a multi-dimensional, information. Okay, multi-dimensional information, so that like, when you ask, when you search for some meaningful information related to particular thing, okay, it will able to search that related information and then give it that back to us. We use that information, to the LLM, and then we try to get a meaning of it. For example, like, okay, here we saw that one, the same thing. For example, here we have a cat. So the cat is having a multi-dimension. I'm just giving like dots. Assume that like it is having a multi-dimension, okay, which is having a value of 0.21. When I use dog, okay, then it is a like 0.23. So now it is 0.21 and 0.23 because they both are animals. That's why they are very close to the each other. But when I talk about house, compared to the cat and dog, it is around like 0.9. It is very far away for the cat and dog. Okay, because house is a different entity. So probably the house might be the cat might be having a some kind of similarity, because for example, dog might be having some kind of similarity, the cat might be a some different where it will live in the house. Okay, so along with the humans, in that particular dimension, that might values might be close somewhere here in the dots, for example, somewhere in the multidimensional. So house, the number what we have in the cat and the number what we have in the house might be close, like these two, for example, because some cats might possibly live in the house as well. So that dimension, they are close. But in other places, maybe for example, if this is a for example like a tail, for example, the house may not be having a tail at all, for example. Okay, so like that, when the data is put there, like it will try to put that particular meaningful information in the relevant data in the space, or like a dimensional space. And when you ask for a question or retrieve the ask for a vector DB to retrieve that relevant information, then it will try to retrieve that one in from the multi, in the multi space, okay, and then give that information which we use for the LLM. So basically, in general, what they do is a semantic, a semantic distance. So basically, like how this vector works is like more like, as I said, that it's a math. It's just a simple math of the numbers, okay, which calculates the distance between the two, between two or three things, or like, okay, multi-text things, and then it will try to find the nearest distant distance information retrieval, and then that will be used. So the distance will be can be calculated, for example, like using like semantic similarities in most of the cases, or like a cosine similarities. Maybe it's the most common cosine similarities, are like most common uses. Check it like, okay, what is it? Cosine similarities means. For example, you might have heard this word Euclidean distances as well. For example, okay, so which is very rare to where like, they will use it. Okay, but otherwise, like the main part here is it will take the nearest distance related information, and then it will give that information back to us. We will see that one. Okay, so when we are searching the vector database, we'll see that one. Okay, so relevant information, and then that information will be provided to the LLM, and that LLM, it will try to formulate that particular information into a meaningful, natural language, and then share that with us. So what the LLM is doing is mostly, the text what you are providing will be formulated and then given to the more human readable format. So these vector DBs, for example, like as I meant, like primarily there's the embeddings, what I mentioned. When they are embeddings, are when we are converting these text into the embeddings. So again, like they use the we use the models, not they. Okay, we are creating the RAG, so we use the models. That models, like. That models like been built by like many people, like for example when they're designing these numeric spaces, for example, so whichever having a very very good optimized way of defining those dimensions, so that will have a very good predictable results when you're searching. So like that, there are many models are available for creating these embeddings. So these embeddings, like once you create an embedding, so you going to store that information into the vector database. For example, some vector databases are like Chroma, FISA, Pinacone. Okay, like that. There are many databases available, vector databases available. You can use Chroma, for example, for this relevant thing. You can use a Chroma. Okay, you can use a chroma, and then in this example, at least, like we are using a chroma. Let put that way. Okay, for example, like, okay, let's I mean, I just put it here, like small text. For example, if I want to put a house, where can I put it? This one. Anybody want to guess? So just tell me, like, between these two or something like that. If somebody want to tell.
Yeah, mostly it should be closer to humans and building, and also probably closer to life as well.
Yeah. Okay. So in one space, like this one is the right place. Okay, in another like a dimension, probably you can put that one to the building and the life. For example, the dog. Okay, so dog. Where can the dog can go? Anybody want to answer it? Okay, so maybe we can put close to the human. That the vector DB will when you create an embeddings, and then when you try to push that information, so that information will be stored in a multi-dimensional space. Okay, something like this. Just a very not exactly the way what we look at it, but yeah. So this exact I mean the meaning behind this one. Okay, so vector RAG pipelines. So how this RAG pipeline is going to be is the first is the ingestion. So during this ingestion, what we do is like we load the documents. So wherever like we have the documents stored somewhere. there. Okay, so we load the documents and we chunk them. We chunk them into pieces. Okay, so we chunk them into pieces and then we embedded them, because we can't store all the document at all the document as one chunk or something like that. Okay, so because we need to have a context, the context, we have a problem with the context limitation, right, as we mentioned. So we can't have too much information. So for example, I can't push one 100 MB of document to the LLM and then ask them to read and then provide me the answers. We can't do that one. Okay, because it is having a limited context space. So that's the reason we chunk them, okay, to the most relevant things, and then we embed them. So once we embedded those information, then we store into the database. Okay, so that is what the part of the pipeline, like the rack, the pipeline injection in the pipeline, the injection part is. So this is the most critical task, or the as for example, if you are a RAG engineer, for example, and your job is to be as a RAG engineer. Okay, so this part you have to understand the chunking and embedding. Okay, chunking and embedding is the place where you are going to spend a lot of time. This requires a data cleaning. Okay, for example, if you are a machine learning engineer, for example, okay, so you require a lot of data cleaning, formulating the data, creating the chains, and then converting that to the embeddings. Okay, when you're converting the embeddings, it takes a lot of resources. So for example, you might use let's say, for example, how many of Apache Spark? Do anybody of Apache Spark? Have you heard about it? Okay, so if you use an Apache Spark on it, something to have this chunking, and yeah, Vaishnavi knows that very good. Okay, so we use the Apache Spark for this chunking and embedding in this, so that it will be really fast. I mean, you can do it in a parallel processing. So for example, in your computer, you cannot use this Apache Spark on your computer. Okay, so I mean, it required a distribution, okay, the distributed systems. Okay, so to run that one. So when you will do that in your local first for doing this chunking and embedding for a sample, and then you run it in the Spark, which we can run it more efficiently, more fast using the Spark clusters, for example. So that is the place where you spend most of your time. Remember that. Okay, then the retrieval. Okay, once you store into the database, the retrieval is a very simple thing. So when you ask for that one, depend upon the what kind of a database are you using, or their efficiencies. Okay, so you send a question, and then the question also should be, like as I mentioned, that the question also should be in embeddings. Okay, so use the same embedding like what you have there in the previous one. For example, the embeddings model what you have used for the injection, use the same embeddings, and then convert that question into again to the embeddings. So you remember that when we are discussing, we converted the dog into 3,5 coordinate. Okay, so we converted that question into the embeddings, and then you search using that embedding again to the database. Now it knows the location, relevant location of that one, and it will do the similarity search. Okay, where exactly the similarities are there. So it will retrieve all that information. Okay, using, for example, internal models like nearest neighbor, top k and k chunks, for example, using the nearest neighbor, and then that information will be retrieved and written back to you. Now you take that data. Okay, so then you take a data, the retrieved context, and then the question, you convert that into a prompt. Okay, and then send to LLM to generate an answer. So now the LLM will generate that answer and then give that back to you. So as I mentioned in the last session, so you need a Gemini API key. Okay, so if you want to do some kind of a assignment for this one, okay, assignment for this one. Okay, so you need to have your own Google Gemini API key for this one. Okay, for this. Of course, I mean, if you want to stop at only querying, Okay. For example, like the retrieval part, ingestion retrieval doesn't require a Gemini API key, but if you want to have this generation, you need to have that one. So if you want to stop there, you don't need it. But if you want to also experience like how these LLMs do, then you require the API key. API key is free again, like you don't need to pay anything for that, and you just have to register to the Google with your debit card, or like even that phone pay also works. I saw that like people are using phone pay as well. Okay, you can put that information, and then you can get it, so it doesn't cost you anything, so don't worry about it, but be careful. Okay, so don't share that API key to anyone. Okay, so once if somebody gets it, that's it, like okay, they will consume all of your money. Okay, so be careful on that one, but otherwise, like for you itself, like it doesn't cost you anything. So this is how, like it will generate this one. So the problems, as I said that, like okay, so it is also having a problems with the RAG as well. Bad chunking. Okay, if you have like too large chunks, okay, then there will be a irrelevant context will come into the picture. Okay, so irrelevant context comes into the picture. Okay, then like LLM has to process those irrelevant processes as well, which costs you a lot. Okay, and if it is too small, then there is a possibility that like missing a meanings. Like the example, we have a dog. We have a dog. Okay, so if you chunk it, for example, let's say the size of 3, then the dog is having a meaning. Okay, then if you chunk it too small, for example, to 1, then it will become D separate, O separate, G separate. So now it cannot find any meaningful meaning between D and O and G. Okay, so that is the problem with the bad chunking. So we have to have like understand your context, understand your data. Okay, and then you have to find the right chunking mechanism. Okay, and or like you have to experiment with the different kind of chunkings, what is good for your data. Okay, and then you have to prepare the chunkings, retrieval failures. Okay, sometimes when you search it, okay, so it might retrieve a wrong chunks as well. Okay, it's because it nearest neighbor, right? Like it's, I mean, if there's someone is near, like I mean, obviously, like I mean, it will take that information as well to that one. So there might be a semantic drift happens. Means like you look for the same thing, but that is not the same thing. Like for example, like you are looking for some related to something like an animal dog, for example. Okay, so there might be some person name or a car name or something, a company with the name DOG, for example. So it retrieves the same thing for the dog, which is nearest, but like there is a meaning drift happens, and then it will fall into onto the company information, but not to the dog, like what you are looking for example. Okay, and context stuffing. So too many chunks, okay, then the model will be confusing. So if you retrieve too many chunks back, okay, then like the model will confuse, and then it will try to give a wrong information. So hallucination still happens. Okay, it doesn't matter whether like you use the LLMs or like RAG or okay, whatever there is a possibility that like hallucinations happens. So you have to be like keep an eye for the what kind of things it is retrieving, and they, based on that one, like you need to keep updating the information in the RAG or like in the LLM models as well, okay, to avoid these hallucinations. Okay, so for example, like basically you might have noticed or like as I mentioned, LLMs never says that it doesn't know answer. Okay, if it is something like relevancy is there. So if when it failed to retrieve something, like it will try to give a different answer. Okay, different kind of a thing. Okay, so if your wrong prompt is weak, for example, like okay, so if you don't provide a rightful prompt, that is a part of the prompt engineering. You might have heard like many times. Okay, the prompt engineering job is one of the job in the near future. Okay, so if you don't, I mean, the reason why the prompt engineering become as one of the job here is like okay, so the domain knowledge expertise is needed when you are creating a prompt. So to become a prompt engineer, one should have a relevant experience in that particular domain experience. For example, a doctor can create a better prompt than, like, for example, IT employee. If you want to retrieve for example, like cancer information, for example, okay, the person who did the research on the cancer can create a better prompt than a normal IT engineer, for example. So the creation of the prompt is a very, like, in the future, okay, it's going to be really very hot topic. Okay, and the prompt engineering is one of the, career, like, even I was watching one Google related podcast. They're also talking about this prompt engineering, and how this is going to be a big thing in the near future. But that prompt engineering is not for the freshers. Remember that one. Okay, so if you are somebody offers you, like, okay, prompt engineering course and it is hard and something like that, but that's not for you. Okay, so that required a domain engineering, sorry, domain knowledge. Okay, so be careful on that one. But the prompt engineering is definitely one of the big thing coming in the near future, like when the agents are developing, because agents are fully depend upon these prompts. Okay, yeah. So data issues. So as I mentioned that, like, there might be some duplicates data. For example, let's assume that, like, okay, okay, so basically there's no versioning. Let's say, for example, you have written somewhere dog, color of the dog is black. Okay, then later on, like, okay, in the next version they realize that, okay, no, it's not black, it's white. Then you write the white, and then if you don't maintain the versions, then, like, RAG is having two relevant informations, almost duplicates. One is with the dog is dog color of the dog is black, color of the dog is red. Okay, then when you ask a question, so it might give a wrong information because there is no versioning, or, like, okay, so this kind of information, for example, or like the documents are now dated ones. Okay, now we look into the demo, like, how this all the knowledge, like what we acquired here, for example, ingestion, retrieval, and generation. Okay, we learn here, like, we'll try to implement in a realistic way. Okay, so this will be going to be fun, so let's enjoy the demo. Before that, do we have any question? Okay, so again, we have okay, so week 3. So we will try to let's go through this week 3 thing, and in this one I'm going to push this code into the repo, so you can download and then you can experiment. So here I divided that one into 3 parts. One is document reader. Okay, for example, if you look at that injection one. Okay, so and then splitting into the chunks, and then doing the vector search. Okay, vector search, and then, like, we have an API to ask the question, and then retrieve the information. So, how many of you already know about how to get this Google API? So, if somebody want to know that, or like you already know, then I don't want to go there into Google and then show it, like, okay, how to get this API. If somebody want to know, just raise the hand. Okay, I will show it. Otherwise, like, I will skip it. Okay, yeah. So one person raised it, so he want to see that. Okay, fine. So how you do that one is, okay, so go to your, okay, Gemini AI Studio. Okay, go to Gemini AI Studio. Then there is something called Get API. Okay, so to do this one, first you need to have, as I said, that, like, you need to have your, for example, like a GCP. Okay, so you need to have your billings, and okay, go to the console. Okay, in the console, you should see the, for example, here in this one, so you should see the billing. Okay, so you should have this payment methods. So in this payment methods, first you need to add your credit card or the debit card. For example, for Indian geography, you can also add the this phone pay as well. Okay, you can add the phone pay as well. So once you did that one, then like, you go to the AI Studio and then, click on this generate API key. Okay. And then create a new API key. So when you're creating it, ask for you, to give a name and then choose a project. So you create a new project. Okay, and then once you create a new project, it will appear like this, and then provide select the project and then provide some name and then click on create key. So once you did that one, then you get an entity like this. You copy this API key, okay, and then keep your API key for this example. Okay, so yeah, that is how like we need to create an API key. So once you create an API key, then like you are ready to do this one. As I said that you don't need an API key. I mean, if you are not doing the LLM functionality. If you are stopping at just searching the vector database, then you don't need that one. But let's look into this. So as I mentioned that like okay, there are three files here. One is for okay, basically what this file do is, so there is a yearly annual for example, let's open this one. Finder. Okay, so this is the document I am taking. Okay, so it's a very small document. Okay, so for example, like Yellow Products is the company name, which never exists in the LLM or like anywhere. Okay, so I just created my own this one. That's why like you don't find any information. Okay, so then I have this annual financial statement and some like okay for the year 2024, and then I put like revenues, okay, expenses, and this and that all, okay, balance sheet and some kind of other information. Only I have only one. I mean, I just using only one document here. Okay, now I'm going to ask the questions on this document. Okay, so by converting this into a RAG model, this is what I'm going to do. Okay, now to do that, first one is like okay, so the first one is here, like so I think you don't need introduction of this notebook, Python notebook things, like you already have that aware. And there is a requirement document. So in case like if you are installing or like testing this one, so install these packages into our environmental Python environment, then use it, because we discussed in the first session. Okay, but almost like most of you already know the Python, and you know about what is meant by Python environment and how to use the Python environment. Probably you can do that one in the for example, like Colab as well. For example, okay, you can also do this one in the Colab. So exactly whatever the things you did in the Colab is the same thing here. But let's see like okay what it is doing. Okay, so as usual, like we are importing the required packages for the Python. So one of them is a PDF reader, because I have this PDF document. So in case like if your documents are not in the PDF but they are already in the text, then you don't need to use that one. Okay, so and I have like I have like other related. For example, this one is for the embeddings. Okay, embeddings package here. Okay, I'm using this one. Let's go through that. And I have this Chrome debug, but I'm not using in this particular file, so you can ignore these two for this file. And also I'm not using this also I'm not using it, so we don't need that one as well. Completely, we can ignore this. Okay, we don't need this one. Okay, let's first load these packages. Okay, now I load these required packages. Now what I'm doing is converting the PDF file to a text format. I'm not running through each line of this code, but okay, so try to understand that like okay, I'm not teaching here the Python. Okay, I'm teaching the RAG here, or like okay, we are doing RAG here. So it is expected that everyone should have like some Python fundamentals. I mean, understanding the Python programming language. Okay, so when this exercise has been done, okay, so what it will do is basically it will read the PDF file, and then it will convert all the text in the PDF file. Okay, what are the text you see there into a text, and then stored into the extracted text. For example, if this is the file, what I will do is I will just delete this one. Okay, so what it will do is like, yeah, it will convert all the text in the PDF and then convert to the text. So here, like, it will go to the every page and then convert that as a convert that page into as an image, and then it will use the OCR reader, okay, using PyTest React, okay, it will use this package and converted that into a OCR readings, okay, and then add to the add to a list all the text. Then once that is done from all the pages, then it will write into a file, okay, all the text as a, like, with the new line character at the end of the each line. So once you run this one, we expected that it will create a file name called extracted text here, which contains all the information what we have in the PDF. Okay, let's run this one. Okay, now we have this file here. So this file contains yellow product, annual financial statement. Okay, like this, we have all the relevant information stored here. Okay, all the information stored here. So are we going to do exactly the same way when it comes to a real world? Is no. Okay, the reason is, for example, in the companies, generally we will be having a similar kind of a documents, all the financial statements, or like all the Confluence, all the installation setups, all the something like that. So they have a particular kind of a information. So for example, now I have a revenue here, I have this one here. So probably I might be interested, I will put like the text will be converted into revenue and then the amount, for example, or something like this, not as a separate line, but I'll put it as a single line, for example. Yeah, somebody's having question. Okay, sorry, yeah, please go ahead. Sneha, do you have some question? You raised your hand.
Also,
Okay, you raised your hand, so yeah, okay, fine. Okay, so you can also convert this one. So this formatting conversion is the one, like, which is very important when you are converting these PDFs or documents into a text. So that is the knowledge you need to get it through expertization and the domain and all this stuff. So okay, so that there is a place where we have the difficulties, just like as I mentioned, like in a data science cleaning. But right now, okay, so we are not interested on, I mean, we are not, our scope is not about that. Our scope is about more about learning the RAG. So now we converted that into a text. Now we have the text ready. Okay. Okay, now the text ready. So now, okay, this is again like not read anywhere because the splitting is come to the next one. Okay, now the first program, what it did is just read the document and convert that everything into a text. So the cleaning, we did cleaning. Of course, we have not done any cleaning here, but in a reality, like, okay, so we read the documentation, we extracted the relevant text, we did the cleanup, okay, and then every all the data is there in the some particular folder from all the information, the private data we have. Okay, next one is like splitting and chunking this one. So on what data we are going to apply this I mean, like chunking and splitting and chunking. So the data what we extracted, that's why, like, we took the output data, output text file from here. Okay, we are reading this data. Okay, in real world, what happens, we don't read one single file, we read, like thousands and thousands and millions of files, okay, GB of files, okay, and then we try to read every file and then do that operation. So in a single computer, in a sequential mode, we're never going to do that one. That's why we use, for example, like Apache Spark, okay, clusters, okay, this kind of a things. We use like data lakes to store this information, like, okay, so we use that kind of a things to do that one. But here, like, we are learning the RAG only. So I mean, we don't need to go to such level. Okay, so yeah, we read this data and then we have that all the information here into this variable, for example. Okay, so now let's run first, load all the required one. For example, if I put print okay, let's see the extracted text. Okay, so now I have all the text in this variable like extracted text. Okay, then I have this split. So I have written a method to split this one. So when I'm splitting it, so here you see this one. This is again a important parameters, like when you are working in the real world. So the chunk size will determine your RAG performance and hallucinations, or like all these kind of things. So we need to have like your own experiments about this, and then you need to work on that one. So for example, let's say I will do the first, I will do the, yeah, I will just do with the 100 chunk size. Okay, and then there's an overlap. So what is this overlap means? The overlap here means, for example, let's assume that there is a okay, so let me take one, for example, let's assume that we have some news here. Okay, let's take this. Okay, let's take this information. Okay, here. So here we have okay, here we have a text here, for example. Okay, so here we have a text. So what I'm trying to tell is, let's assume that I want to split this one. Now, if I split this one into something like a 50-50%, for example. Okay, this is like chunk 1 and this is chunk 2. Okay, now when you look into this one, let's say for example you don't know anything about it. Okay, then I will give this information, the chunk 2 information to you. Okay, so does it make any meaningful? No, right? Similar way, if I give a chunk 1, doesn't make any meaningful? No. Now when these two are together, then it bring a meaning. But now the question is, how do I know that, like, okay, this is the second part of that first one? Okay, it's very difficult to figure it out, like, okay, uh, what is that, like, for example, the connection point between these two. So that's the reason, like, we need to have, okay, something like this. Okay, so what happened now? Okay, winter storm will be impacting several areas of the state starting this afternoon. So the connecting between these two is this part, impacting several. So that is the overlap what we are talking about here. When you are checking it, you should create a overlapping. You cannot create a overlap with 100, means like, okay, then it become as a duplicate. You put the two sentences the same way, like, two times, then 100%. So it just have the same things for that one. So it's not a good idea. At the same time, you cannot just tell, like, for example, like, let's say 100, and then you put a chunk of, like, suppose, like, for example, 5. So then what happens? Then you will be having a something like this, for example. So this also doesn't provide a right connection between the chunk 1 and chunk 2. That's why the chunk size, this size, and the overlapping between these two should be, optimized, so that, like, when you are creating a RAG model, for example, which can retrieve it properly. Okay, so that is like very important. That will happen only, like, with your experience in the data, what kind of data you are looking, and these kind of things. So now what we did is we took the text, and then we are splitting it, and then we are creating an array of chunks which we created. Okay, let's see, for example, with the previous data what we have. So I'm just creating a method. Then here the actual things are happening. Okay, let's say, for example, we try to stop this one, and then here we put a chunks, and then see how the chunks are. Okay, so I have this function here. Now I'm running this one. Okay, now you see the Okay, now let's take this one too. Okay, here, okay, and then you see, we'll see the how the chunks are. Okay, so now we have the chunks something like this. Okay, still we have here third space. Okay, yeah. Okay, so we have chunks here. So each one is having a chunk something like yellow products annual financial statement for the year ending up to here. Okay, so one chunk. Now we create the similar way again, like not that big. Maybe we create with the chunk size of 5, for example. Okay, yeah, I want to show something. Okay, now you see here the income statement. Okay, here it is ending with the income statement and starting with the income statement in the next chunk. Here is the gross profits and starting with the gross profit here. So that is how like they both are connecting. Now if I change this one to 5, and then again like if I run this, okay, then you see it here. Okay, so income statement DE description. So the DE what we see it here is coming from here description. So it's very difficult to find a connection between these two chunks if we have a very small overlapping. That's why we should have a like some good overlapping. That again like depends upon your data. Okay, so we should be very careful about like when you're telling like chunk size and overlapping. Okay, so I hope you understand what is the meaning of this one. Okay, so now we have a now we have a chunks. Now we are creating these enumerates for this one. So enumerates in the sense that what we are trying to do it is for the each chunk we are trying to provide a, for example, an ID. For example, in the database when you are working on, you might have a unique ID or like employee ID, for example. Okay, primary key, for example. Okay, so we are trying to, for the each chunk, we are trying to provide an ID, because later on when the vector search is happening, when it is retrieves the meanings like in the coordinates, so we should know about the actual text belong to that one. Okay, that's why for the reverse, for the reverse proxy, for the reverse proxy of finding the relevant information in the text, so we need to have these kind of a IDs for that one. So what we are doing it is like we are trying to create an ID, related ID, and the chunk for this one. Okay, now let's look into the chunk document. Okay, so once we execute this, okay, now we have created a 7 chunks, nothing but like, okay, what we see here, 1 2 3 4 5 6, I think 7 somewhere, like I didn't put here. Yeah, okay, so maybe like starting with the 0 1 2 3 4 5 6 7. Okay, so it is having like 7 chunks. Now try to print that document. Now we should see a unique UUID. Okay, a unique identifier. Okay, see, this is an ID, unique identifier, and then like we have the same text what we have there before. So now we have a connection. So when it is retrieved, it knows that like, okay, which ID related to that one, and then it will retrieve that information related to that particular similarity. So that is what like we have here. Then this is the place where we are converting that enumerates or like the text into the embeddings. So for this one, we are using a model called EB model. Okay, so this model we are using, this is from, I think, like Facebook. This model has been generated by Facebook actually. Okay, so we are using this embedded model for this one. So first we are creating from this one, we are creating a model to use, and then using that model, we are going to create a chunks embeddings for that, for the data what we created. So this model you can, I mean, depend upon the company and okay, so their experience and all, these models you can change. Maybe there might be some efficient models are might be coming always. Okay, we always use these efficiency models. Okay, when we are converting into the embeddings. So that's like these are one of the biggest operation. So it takes some time to create these embeddings. Let's do that one. So here you see that we have a text. What we are doing it here is from the chunk document, from this one, we are separating text and then the IDs. So we only going to convert this in embeddings, for example, only for the document or like the information, okay, not the IDs. So then we need to have the same information relevant to that one IDs as well. That's why we are separating these two here. Okay, so now let's bring the model alive. So here what we are doing is just loading the model. Now we are going to convert that into the embeddings. Okay, now run these embeddings. Okay, now we have the embeddings here. Okay, now let's see if you try to bring that embeddings, we see the same things like what we have noticed in the examples. Okay, now that particular embeddings has been converted into a numeric, okay, a numeric thing, and we don't need to understand this one. Okay, we can't even understand this. Okay, so we don't need to worry about what is the meaning of that one, or we don't need to spend a time on this one, like what exactly that minus means. It's in a multi-dimensional space. It is having a coordinates, okay, related to that particular thing, how it is divided, how it is has been modified. Okay, we don't need to worry because we are not vector engineers or mathematicians. Okay, that we are not of that part, so we are more like into the IT space. So what we have to understand is it will be converted into the coordinate space in the multi-dimensional space, okay, with a lot of features and and meanings of those that information. So like this, it will convert into the embeddings. Now, what we are going to do is we are going to store this information into the vector database. So in the vector database right now, for example, like I'll just use 3 here. Okay. So because I'm already using created 2 of them. Okay. But I'm just using the 3 so that like you can see that one. So what we are trying to do is like just like in a normal database, it is also having like, its own schema. Okay, so we are sending that schema information to this database to store that information. So like that, we are just storing that information. First, we are creating a Chroma database, and then we are trying to put that embeddings into that one. Okay, let's first create a database. Okay, now the database 3 is created. Okay, 3 is created. Now we are using these embeddings, which is created, and then see we have IDs in the collection. We are creating a collection and then adding IDs and then documents, the real text, and then their embeddings. Okay, so we have the unique IDs, the IDs what we saw it here. Okay, and then the actual text of relevant one, and then we are adding a embeddings of that one. Okay, so all this into a collection, and then we are adding to that particular vector database. That's it. Now we are created the vector database. Now the next thing is like we are going to search that vector database with our required.
One question.
Yeah.
So, for example, now we are using this Chroma database for this local testing, right? So, yeah, but then, like, say, of course, we can use like any other database that we can, or is it like,
Vector. We can use any vector database.
yeah, so like like enterprise level database, we can just
Yes.
connect like that, and yeah, we can start
Yes.
using. Okay.
Yeah.
And the one thing is that like because now is it because like we have to use only of course the vector databases, right? Because we can't use any database or something.
No, we can't use other database. We have to use the vector database only.
Only, yeah. Okay.
Yeah.
Okay. Thanks.
Okay. Any more questions? Okay.
One more question. So, because you already mentioned this before, of course, now this example you have given for one specific PDF document. And of course, like in real world, of course, will be thousands of documents or like say the SharePoint collections and all the stuff will be there. And of course, like when we are doing this kind of like, splitting the chunks and of course, like when we create the chunks and of course, it's like an iterative process of figuring out which chunk size will be best for our needs. But then it will also vary based on the what do you say the document types and so on, right? And all the stuff as well, right?
Yeah, when they are processing that particular document, so they know that one, like, okay, so what kind of a chunking and overlapping we need to take.
Okay.
Yeah, if
So,
it's a
and of course,
conversion,
yeah,
yeah,
yeah, you can have like then of course have all these things. Like of course we can just loop it over or based on document type or the document classification itself, create like a separate chunk size and all the
yes,
stuff based on
yes,
that one, and then store it everything into these kind of things. Okay,
exactly.
yeah,
Yeah,
thanks.
exactly. Yeah, that's why, like, I mean, that is a more painful process.
Yeah,
Okay,
yeah, yeah.
identifying like thing and okay, so yeah.
Mm, yeah.
Okay, so now we have the database ready. So now, like, okay, so we are done with this in the pipeline. So we are done with these two of those items. Then let's go to the vector search. So again here, like, the new things came into the very first time, like we are adding a Google API here, for example, Gen API. Okay, so and then we are going to use it and then do it. So to do the vector search, okay. So as I mentioned that only need a API key if you are calling an LLM model. Okay, so if you are only searching and then looking into the what it has searched, okay, so then you don't need that one. Let's see, for example, okay, again, like as I mentioned, so we have to mention like which model, because you remember when you send a question, that question has also to be into the embeddings. Okay, that question also need to be converted into the embeddings. That's why like we have a model here. Okay, so to convert the question into an embeddings coordinates and then send that coordinates so that it will find that nearest coordinates for that one. Okay, so here we are again like just like in a previous program. So we are calling the model. Okay, let's run this one again. Now, yeah, we are good here. Okay, so we loaded and then we are just initiating some variables. So in this one, like we need to have this model, the model name, and then here we are creating a model. Okay, and then we are also defining a generate embeddings just like what we did before. Okay, for the question, this is the question which we are going to send, and then it will bring that embeddings for that question. Okay, so just we are calling a method here, preparing a method for next question. So now we are ready with that method, and then now we need to take the database, the 3 database which we created. So again we are creating a Chroma client for that one. Okay, and then calling the previous collection which we created. Okay, the same collection what we used. Okay, now here we are trying to create a Gemini API client, okay, using the Gemini API key which we have here, and also we are using Gemini 3 Pro preview model for our LLM. So these two are been defined here. So exactly we are going to create a client here. Okay, so we don't need to quickly execute this one. As I mentioned that only if you want to interact with the LLM, so you require to have this one. But anyhow, like okay, anyhow we have the code here, we can execute it. So first we are creating a client, and then we are defining a call Gen AI, means call LLM, and then we are providing a prompt here. So this is the prompt engineering what I mentioned before. So creating this this prompt, this is simple prompt, okay, but in the real world, prompt engineering play a major role, like when you are so we depend upon the prompt only, like the LLM can understand like what you are expecting, and then it will do that. So once you get a context, okay, so you have to send the context and the question as well to the LLM. So this context is the one like is the one like we are going to use it. Okay, so this context we are adding all the chunks into a context, and then we are sending that context along with the question what we are going to ask. And then we send that information to the Gemini LLM. For example, I don't use Gemini, but any LLM. So we send that information to the LLM, what model to use, and then about this prompt. Then it will respond back with this when you call this function. So this is what it do. So let's execute this one. Okay, now we have a question here. So what is the revenue in 2024? So what we are doing, the very first thing what we have to do is generate the embeddings for that one. Okay, with this, for example, let's put this one again as a comment, and then print. Okay, query embeddings. Okay, so what we are doing is nothing, taking the question and generating the embeddings for that one, so that we can see the again like similar similar things like what we saw before. So it has created a lot of dimensions for that one with this one. Okay. So now the next thing what we are doing now is okay. So okay, in the collection, the vector database collection, we are querying with these querying embeddings. So we are sending the queries and then asking to include the documents and the metadata like which we provided, and then we are telling that like how many results we have to retrieve, how many similarities we have to retrieve. We can't retrieve all the similarities because our context size for the LLM is small. Okay, so and then like if you give like too many results, okay, then the context size will increase, then the LLM cannot answer it properly. And if you put less, then the context size is very less, it cannot even answer like answer the question like, okay, what you are providing. That's why how many records you retrieve, for example, in the database, when you're doing a normal classical programming, when there is a, for example, search, generally what you do, you provide a pagination, for example. Okay, so for that one, first you limit only to the 10 records and then do that one. But I'm not exactly the same thing. I'm not telling it. But here, whatever the things you retrieve, here pagination doesn't work because as you add a pagination, it will become a bigger and bigger, and the context become bigger. So we have to limit the number of things which you retrieve from the database. Okay, so here like I'm mentioning like as a 2 here. Okay, so maybe I will change to 3 for the time being. Okay, for a symbol. Okay, then all the results will be here. Okay, then let's see what kind of a results it retrieved for the question, for this question. Okay, so now let's run it. You see, okay, it has retrieved these IDs, these 3 IDs. Okay, and then for example, let's see revenue in 2024. Okay, so now we see the documents what it is retrieved. It retrieved description, revenue, okay, cost of goods sold, okay, gross profits, operating. Okay, here we have some revenue information. Okay, and then okay, yellow products, annual financial statement of the year embeddings, income statements, expenses, okay, operating income, interest expenses, okay, earnings before tax. Okay, so these two things. Okay, even though we don't have a total revenue here in the second one. Okay, in the second document, if you notice that there is no revenue here, but it is a nearest nearest one. That's why like it has tried to get that one. For example, if I put this one to 2, for example, okay, then the number of things which it retrieve will be less. If I put less 1, then it will try to bring the most nearest one. Okay, so it will try to bring only the nearest one which might contains this revenue, for example. Okay, yeah, revenue. Okay, so you don't have the other things here. Okay, so how much size you want to put it in the response is again depends upon the how your documents are, and okay, how this kind of information is there. Okay, it's a fine-tuning parameter which you can play with based upon your data. Okay, how much chunk size is, okay, like that you can have to define this number of results as well. So for the time being, let's say for example, I will just put only one. Okay, I will come back. Okay, so now I add this one. So now what I did is, okay, now it is like, okay, I'm converting that all these what the results what required the documents. I only need this document. I don't need all these unique IDs and all, because this is the only thing I'm interested. Now I'm collecting all those documents information to the red chunks, and then I'm going to use that one for my next activity. So now I just ran so that like I will just drill down all the things. This is the only information I required. Okay, now finally we got the chunks. We searched. Okay, we retrieved the information. Now we are going to the LLM. So as I mentioned that earlier, so we already created a function for calling the generative API, and then we have these relevant checks, which is having only one at this moment. If there are two, then we have to add that all together into multiple. Then we have to convert this into the context, okay, and then send that one. So now I'm going to call this and then see like what it will answer. Okay, so now it is calling the LLM, that is a Gemini, LLM model with all the information, and then it will try to, okay. Now you see that like, okay, based on the context provided, the revenue is this much because the question what we asked is only that much. Now we change the, okay, we change the question. Okay, for example, I will change this question to this one. How much interest paid in 2024? Okay, so here the data what we have here doesn't have that answer. Okay, now we try to see like what happens. Okay, so this is relevant information. Net cash, the nearest one is net cash used in the, what we are asking is how much interest paid in 2024. Okay, so the cash used in the financial activity, something like that, it showed. Okay, now if I send the question, so most probably LLM cannot have that information here in this context. Okay, not have that information related to this one. So most probably it will provide, okay, there is no information regarding the amount of interest paid in 2024 because this is the only data like what we set. Now what we do is we change this one to, let's say for example, 4. Okay, now we do the exactly the same thing. Okay, now we have some information. Now you call the LLM. So mostly because we have 8 there and then we are already like retrieving 4 make 50%. Okay, see the interest expenses is like, okay, this much. So what happened now here? So these parameters will play a major role like chunks, size, overlapping, and then as a, for example, the results what you are retrieving. Okay, you have to play with this one, and then from vector database you have to retrieve that relevant information, and then send that to the LLM. So LLM will answer that questions. Okay, so this is what like we did all the parameter tuning like 4, okay, whatever the things, and then we see that one, okay, yeah, we are getting relevant information from the vector database. Now the next task is like to make these things available for like the use. So that is a way like we go with the APIs, for example. So okay, so APIs are something like, we don't, I mean, nobody will use this kind of a programming like IDE or something like that to retrieve that one, right? So we have to provide them with a proper solution where the end users can send the questions and then retrieve the information. So here in this case, we don't require these two because it's already been done, and only we have is like this DB model which we are, I mean, database which we are created with the vector, all the relevant information. So now what we do is we just only convert this third into a more dynamic approach into an API. So what we did here, exactly the same thing, nothing new. Okay, so exactly the same thing. The only thing is like we added a fast API, which we saw that in the previous sessions, how to create an API. Then we are sending a question. So that question is a like as a post operation, you send a question, then take that question, convert that into the embeddings, okay, and then retrieve from the database, and then and then call the Gemini API, okay, and then retrieve the answer. So exactly the same thing like what we did in the 3. The only thing is an API now. Okay, now let's run this API. The API we saw it in the previous week 2 and week 1 also. Okay, so API is again like if you are a newcomer, okay, API is a very classic example. How you interact with your backend from the front end, for example. For example, like React JS or like Angular JS or something like that. So if you want to show some data on those pages, so one of the way of communicating with the backend servers are through REST API. So this is the REST API what we created here. Okay, it's not nothing fancy or okay, super complex. Okay, it's a very simple thing where we created this one. So now we run this particular API application startup completed. Okay, now we take the this post operation. So in the post operation, we are sending a question. So the question will be in this format. Like, okay, this is the question. Okay, what is the company's total expenses only? Okay, we have a different question. Now we send the request to the API, and then let's see. Okay, so yeah, here is the answer. What is the company's total expenses only? Okay, based on the financial data provided in the contest, the company's total expenses are this. Here is the breakdown of the calculation. Okay, what is the company's total expenses? Okay, get me only expenses, no other information, for example. Okay, I'll just send the same question now. Let's see what it will answer. Now this is like, information is the same. Vector will retrieve the same information, but the LLM is the one, like, who act on this question. So it will change a little bit, answer, like based on the content. Here is the total expenses. Okay. So for example, expenses, for example. Okay. So I mean, like, if the prompt is good, then we can improvise this answer to a better way of retrieving it. So that's a prompt engineering side. But otherwise, like, now we have our own data, and then we have our own, okay, this kind of information. Okay, so yeah, so this is all about, like, a RAG. For example, like, if you really want to go a little bit understanding, and then want to learn a little bit more on that one. Okay, I have this GitHub, where I have this RAG LLM demo. Okay, for example, so here I use a different data. So what I used here is for example, a story. Okay, a story, for example, the magical sword, from this book called, I don't remember, yeah, Chandamama. Okay, so I took this story, okay, and then I converted that into the RAG. Okay, all this one in this example. Okay, and then I asked the questions to I mean, exactly the same thing. The only thing is it will run in the Dockers. Okay, so I just provided all the how to set up this one, and okay, how to run this one. Okay, so once you have this, okay, then all you have to do is go and ask the question, like, okay, for example, like, what is the summary of a magic sword? Okay, so when you ask this summary of this magic sword, then it will, from the RAG, it will retrieve all the relevant chunks and information, and then AI will, process it, and then provide it, provide the summary of that one through LLM. So if you want, you can also do the experiment. Okay, all the source code is here. You can just has to follow this demo as it is like. Okay, so we have that some extra information about the RAG if you want. Okay, so yeah, this is all about the RAG and how to implement the RAG, and how to retrieve it. Okay, so now, yeah, I'll open again, uh, open the doors for the questions. So if you have some questions, yeah, please, this is the time to raise.
Surendra, one question from my side. So if you go back to your API program, so yeah, so now you have this one, right? So it's pretty much like, say, of course, you're opening the connection to the database now, and then are you sending all the chunks of that? Like, how is it only querying the relevance parts from the database? That's where
Yeah,
I'm
because
just looking.
here is the question. So only question things I'm embedding it.
Okay, okay. Okay.
Yeah,
And
okay,
where
and
it is
then
actually searching?
here is the collection. Okay, in this one it is
Okay.
querying the search, and then
Include.
you're asking to n results count is 4.
Okay. Okay. Can you go up just a bit? Like, say, I'm just wondering, like, can you go to the collection where it is defined? Collection, yeah, chroma client. Okay, it's a client. Okay, got it. Now, yeah, yeah. Okay, now it makes sense. Yeah, I didn't notice it properly. Yeah, this is clear. Thanks, Surendra.
So any more questions from any?
And one other thing. So now, for example, we have one document. Okay,
Hmm.
so the source is pretty much clear. It's grounded. But
Hmm.
then if we have more documents in our system, so basically
Hmm.
our RAG is containing of thousands of documents, and of course our LLM is responding based on the results. But how
Hmm.
can we also include the source? Like
Uh,
how, like, say, stating that, like, okay, this fact is grounded on this document and something like that.
yeah, that is where, like, you work here. Okay, so
Okay.
for example, like, okay, this is the place where you okay, so these three. Okay, okay, this is the place where you work on.
Okay. Okay. So now I can add the file name, for example, as
Hmm.
a separate.
Exactly.
Okay.
Exactly.
Okay. Yeah. Okay. Good. Okay. Okay. Thank you, Surendra. And what is the limitation to this API? So, like, what is the limitation for the free tier? So, is there anything like that?
Not
The
sure
gem.
about like how many API calls you can make.
Mm,
Okay, but yeah, I'm using the paid one. Okay,
mm,
so yeah, I mean yeah, I never yeah, so I never
okay.
yeah have that one. Like I don't know. Maybe I need to check it.
Okay. Because there is also this in this Google AI Studio, for example, for me, there is already an API key that shows up like a default Gemini project.
Mm, mm,
So
mm.
can we use that also, or we need to create a new project because it
I
automatically said
think
it's
it
a
can
free?
use that one as well. Okay,
Okay,
it that
okay,
one as
yeah,
well. Okay, yeah. Again, like okay. So when you are done with this one, so better I mean, just go
mm,
and delete. So that
delete
because I
it.
give it the demo, so if somebody because they can see my key here.
Yeah,
Okay, so yeah, anybody can use that, and then it can take away all the money from bank. Okay, yeah. So I deleted that.
and Surinder, just one thought, like, are you also planning to also, show like at least in the like in the latest, classes, like like deploying to like say GCP cloud or something like that? And is that in
Yeah.
the agenda?
Yes, yes. There's the last
Okay.
week we are going to talk about the deployments. Either like for example, using Docker Compose,
Mm,
okay, if possible like into the
okay.
GCP Vertex, okay. So it depends
Okay.
like on
Okay.
the time and all this stuff, yeah. But we
Okay.
show
Okay.
like
Good.
how entire system how works, like okay. So
Yeah.
yeah,
Yeah. Okay. Yeah. Great. That will be also very kind of kind of real world
yeah,
application in that sense. Yes.
exactly. Yeah,
Yeah.
yeah.
Yeah. Great. Thanks, Surendra. It was really fantastic.